In this video, we are going to consider another coding problem, which is called interleaving strings. So for the problem, you are given three strings, S1, S2, S3, and you have to find whether S3 is formed by interleaving of S1 and S2. So here are some examples. So given the string S1 and S2, the first S3 string is an interleaving string and the second one is not. So let's look a little bit deeper into these examples and try to see if we find a pattern and if we can break down the problem and come up with a solution, and then later on we will try to optimize that solution. So if we look at S3, then it is A, T, B, B, C, B, C, A, C, right? And S1 is AA, B, C, C. And S2 is D, B, B, C, A. Now, let's look at the first character in S3, which is A. So here, if let's suppose that there is a function is interleaving, and that given S1, S2, and S3 returns true if S3 is an interleaving string of S1 and S2, and false otherwise. So if we look at the first character S3, then we find that the first character of S1 is matching, but S2 is not matching. So probably we could call the isInterleaving function again, but this time with the next character, which is A in S3, next character which is A with the substring A, B, C, C in S1, because the first character of S1 matches with the first character of S3, and then the same string S2, and then S3 starting from index 1. So this is one case. The other case would be if the first character did not match the first character of S1, but it matched the first character of S2, then in that case we would pass in S1, we would pass in S2, and we would pass in S3. And there is a third case if it, there are two more cases, if it matches both of them, like then we would probably need to call the isInterleaving on line 14 and line 15 as well, and take an OR of that. So these are the three cases. Let's highlight the three cases. The case one is when the current first character in S3 matches S1. The case 2 is when it matches first character of S2. And third case is when it matches both the first characters of S1 and S2. So let's try to build up a recursive solution first. So if we can write down the recursive solution for the function is interleaving, then the base condition would be, so imagine the situation when S3 is empty and S1 and S2 is not empty. So if S3 is empty and there are characters in S1 and S2 or S2, then we return false. The other base condition is if S3 is empty and there are no remaining characters in S1 and S2, then return true. And then we build on the recursive solution. So here the recursive solution would look like the recursive solution would basically say is interleaving S1 1 to end, S2, S3 1 to end, or is interleaving S1, S2 1 to end, and S3 1 to end if S1 0 is equal S3 0 and S2 0 equal S3 0. And otherwise, if it matches one of them, then basically it would, let's try to copy paste really quick. So this would be, we would get rid of this condition, and here this is the case, and for the other condition, let's copy paste this. So this would be the case. Now this is fine. This is a recursive solution and it would work, and the time complexity is, since for each node we would be visiting is interleaving at most twice, and there are n characters, so the time complexity is going to be order 2 to the power n. But let's see if we can do better than this. Can we somehow, because we're solving soft problems here, and there might be cases where you're basically solving the same subproblem over and over again, and that is where we should try thinking of stuff like memoization, and basically storing the value in a memory, in a 2D array, for example, and then getting those values if you have already seen the same subproblem again. So the very simple way of doing it would be, so when you call is interleaving from index I to, for index I and for index j and for index k, then basically you are you would need to store this information somewhere else, and later on when you're solving the same subproblem again, then you would need to refer to the solution, and you can use it to reduce the time complexity basically. So I leave up the memoization part up to you. Let's try to quickly code up the recursive solution. It shouldn't be hard. So is interleaving S1, S2, S3, and here we have said if len of S3 equal 0 and len of S1 not equal to 0, or len of S2 not equal to 0. If either of that is the case, then we return false. 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 Alright, let it be. If len of S3 equal 0 and len of S1 equal 0 and len of S2 is also equal to 0, then we return true. Else if S1 0 equal S3 0 and S2 0 equal S3 0, then we basically copy paste this and we return it. If S3 is 0, then we copy paste this part and return it. If S2 0 equal S3 0, then we return this part. Alright, so this is a recursive solution for this. I would like you to basically optimize it, basically see if you have seen the same subproblem again. Then you don't need to call the recursive function. You can use the one that is stored in the memory and basically return that. So basically there would be something like basically in memory you would be storing whether the current string that you're seeing, whether for two substrings in S1 and S2, whether you have seen the same subproblem again. And if so, then you would return it from memories where you have stored it, otherwise you will call the recursive function. So yeah, I hope you enjoyed the video, and if you did, please press a like and subscribe to the channel. Thank you, bye.